Alright guys, this is question 4 of the one-dimensional kinematics problems. It's relatively straightforward. It's an example of vertical projectile motion in one dimension. So the problem is a stone is thrown vertically upwards with a speed of 18 meters per second. How fast is it moving when it reaches a height of 16 meters? That's question A. And question B is how long does it take to reach this height? And C is why are there two answers for question B. So as usual, let us first just establish our coordinate system, so x and y, and we will make upward positive y, downward negative y, and x is irrelevant in this problem. So if we were to draw the stone and it gets thrown up with some initial velocity, it goes up all the way. Eventually it reaches a maximum height where it is temporarily no velocity, and then it starts going down, and then it hits the ground again. So this height here, we can call it y max maybe, and we know at y max the velocity is 0, and the initial velocity we are given, so this is the initial velocity, it's going upward, so it's positive, is 18 meters per second. And then the other thing that's very important here is gravity is always acting downwards, so the acceleration is actually the acceleration due to gravity, which is negative 9.8 meters per second. So the minute the stone starts going up, it immediately begins to slow down, and it slows down until the point where it reaches a 0 velocity, and then it starts going downward, so its speed becomes more and more negative until it reaches the ground. So hopefully that intuition will make it a little bit easier for us to actually solve it. So the first question is, how fast is it moving when it reaches a height of 16 meters? So let's imagine 16 meters is here somewhere. And let's make it, let's just call it h for height. And I mean the ground can be set as, y0 here. Y can be 0 at the ground, like y initial, and then yf in this case. So h is just yf minus yi. But let's just use h, simpler like that. Okay, so we don't have any time, so we shouldn't use any formulae that involve time. It won't really make much sense. So what we'll work with is this equation, vf squared, so final velocity squared, is equal to initial velocity squared plus twice the acceleration times the distance, and the distance in this case is h, because we are interested in how long or how fast it was at this point at h. Yeah, how fast was it there at h? So we want to obviously make h the subject. We want to solve for the final velocity. So the initial velocity is 18 meters per second squared plus 2. Now remember, a is negative 9.8, so negative 9.8 meters per second, and the height is 16 meters. So we're probably going to need a calculator here. So 18 squared is 324, and then we must square the units as well, so meters squared, seconds to the minus 2, and then here, because we've got 2 times a negative number here, we're going to have a negative, and here we're going to need the calculator definitely. So 9.8 times 2 times 16 is 313.6. So this is 313.6, and let's make sure our units are right. Meters squared, meters there, so it's meters squared times seconds to the minus 2, so we have the correct meters here, the correct units. and this is just 10.4 meters squared. So we know what the final velocity is squared. We don't want that, we want the actual final velocity, so we just take the square root of both sides. So therefore VF is the square root of 10.4 meters squared seconds to the minus 2. So meters squared becomes meters, seconds to the minus 2 becomes seconds to the minus 1, and 10.4, square root of 10.4 is what? I'm not sure, so we'll have to use the calculator again. It's 3.22. So it's 3.22 meters per second. So this is a reasonable answer. So that means when it reached 16 meters above the ground, this is the speed at which it was going. Now question B asks what? So question B wants to know how long does it take to reach this height. Well, now we have to use that quadratic equation from the equations of motion. So that is the one that says the distance traveled. In this case we're interested in h, is the initial velocity times time plus a half times acceleration times time squared. So again we know acceleration here is g, which is negative 9.8. So before we even do that, let's continue to manipulate this algebra. Let's write this equation in the form as follows. Let's write this as a half at squared. Let me just write that squared a bit better. Plus vit minus h is equal to 0. So basically we want everything on the same side of the equal sign. The reason why I want to write it like this is that if we think back to mathematics, we have the quadratic formula. So let me just, if we have an equation of the form ax squared plus bx plus c is equal to 0, then we know that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Of course, in this case, a is not acceleration. I'm explaining this piece here, just for reference. Oh, there I went over it by mistake. But anyway, so now this equation here, which we can just call equation star, for example, we can solve for t using the quadratic formula. It's going to be equal to, so negative b in our case is negative vi plus or minus the square root of vi squared minus 4. Our a is a half a, actual acceleration, half of acceleration, and our c will be negative h. So let's close this square root carefully, alright, and then divided by 2a. So again our a is a half a from equation star. We can do a little more simplification. Try and always simplify the algebra as best as you can before plugging in numbers. So we still have vi squared. Negative 4 times a half is negative 2. But now you see here there's a negative times a negative, so we're going to get a positive value here. So we're going to have vi squared plus 2ah. Let's close the square root. And then 2 times a half is just 1, so we just end up with a. Now when we plug in the values, we'll see what's going on. So negative vi will be negative 18.0 meters per second plus or minus 18.0 meters per second all squared plus 2. Now remember, acceleration is g, which is negative 9.8 meters per second to the 2 meters per second, and h is 16. Let me see if I can fit this one in. 16 meters, just about. And now let's close the square root. Remember acceleration, which again is negative 9.8 meters per second. So I mean we're gonna need to put a calculator here. Okay, let's do a little more simplification. So we get negative 18.0 meters per second to the minus per second, plus or minus. We did calculate 18 squared earlier. It was 324 meters squared seconds to the minus 2. This is going to be a negative answer here. So we're going to have a negative. I think it's 313, but let's just double check. 16 times 9.8 times 2. 313.6, yes. 313.6 meters squared second to the minus 2. This thing keeps looking like a question mark. Alright, and then we go, and all of this divided by negative 9.8 meters per second. So, I mean, we can, again, if you like numbers, we can just continue. So negative 18.0 meters per second to the minus 1 plus or minus the square root of 10.4 meters squared per second squared. And plug in all this in the calculator, we're going to see that whether we plus or minus, this number is less than 18. The square root value here is less than 18. So you're going to always get two positive answers. Both your answers are going to be positive. So if we plug this into the calculator, we get two answers. We get 1.51 second, or the other one is 2.17, I think. 2.17 seconds. Just to make sure, you'll see there, this becomes meters because the square root cancels. So there's a meter there, meter there, meter. The meters all cancel, and then this will be second to the minus 1 minus 2. So units are correct. So we might ask now, we get two answers. They're both positive. They're both reasonable. So which one do we take? Well, we take both answers. So question C asks, why do we have two answers? The reason for that is the stone started at the bottom. It went all the way to reach the top, and it came down again, and it crashed. If 16 is here somewhere, the height of question, the stone reaches this point. Just show that it's going up, going up, going up, flat over here, going down, going down, going down, going down. It reaches on its upward trajectory. It takes 1.51 seconds to reach that point. Then it moves a little bit further, and then 2.17 seconds before it reaches here. So that is why you get two answers in that question. Alright, that's it, guys. We'll move on to question 5. It's a bit long. We'll do it in a different video. Okay, thank you.